From everything that we have said so far, the technologies that are used to enable compute cloud offerings must address a number of requirements. Clouds must provide fungible resources, which means that the resources can easily be repurposed to support different customers, potentially even with different types of requirements. Otherwise, if cloud providers have to allocate and maintain physical resources for every one of their customers and the exact same type of physical resources as what the customers at least think they require, then the economic opportunity for cloud computing just won't be there. This fungibility is also necessary in order to deal with some of the heterogeneity that exists within the cloud resources. You may have different generation of servers, maybe even different types of servers. And you don't really want the users to have to deal with that. You don't want them to be exposed to the level of heterogeneity. Clouds must integrate resource management methods that support the premise of cloud computing. So they must be able to dynamically adjust the resources that are allocated to cloud users, depending on the need. So this needs to be done very flexibly, very elastically. Such management methods must be able to operate at very large scales of thousands and tens of thousands of nodes. The scale is important both from the perspective of the cloud provider, so how many resources it needs to manage, but also from the perspective of the customers. Customers often look at clouds for their resource needs because otherwise they don't have access to sufficiently large resource pools. So then clouds must be able to provide to potential customers the ability to allocate really large collections of resources for their individual needs. So the scalability is required with respect to that dimension as well. Once scale is introduced, failures become inevitable, really. If we have some probability that one component in the system will fail, the more such components we put together, the greater the probability that something in that collection will fail. So we have to incorporate mechanisms to deal with failures. Clouds, by definition, are shared resources across multiple tenants. So cloud management has to deal with this multi-tenancy. It has to provide mechanisms that guarantee performance and provide isolation across multiple workloads, multiple tenants. We cannot have one misbehaving tenant that will somehow take control over all of the resources and punish and hurt the performance of the remaining tenants. And finally, an important concern that must be addressed is isolation of the state that's being accessed in cloud systems. With this respect, clouds need to make guarantees regarding the privacy of their tenants' data and the security of the execution environment that the cloud guarantees. Another aspect of security is also to make sure that there are privacy and security guarantees not just across tenants, but also that the cloud provider isn't going to somehow access or take advantage of the state that is managed by individual tenants. And then also the other way around, that the cloud computing layer is protected from certain vulnerabilities that exist within a single tenant, and therefore that one tenant isn't going to affect the entire cloud platform.